Now another question, which of the following represent hybridization of ethylene? Ethylene, A, SP, B, sp3, C, sp3G, and D, sp2. So how are we going to get the hybridization of this? It's simple. How do you calculate? We have to know what is ethylene. Ethylene is an alkyne functional group. Alkyne. Alkyne. Has alkyne functional group. It has alkyne functional group. Of course, when we said ethylene is alkyne functional group, and we know that alkyne functional group have a general formula of CnH2n minus 2. Ethylene from the word ethene, it means that it has an n equals to 2. So we now have C2H2 times 2 minus 2. So we now have C2H4 minus 2. So we now have C2H2. So this is ethylene. Ethylene. So but now the question is, how is the structure of ethylene look like? The structure of ethylene looks like this. It has one hydrogen here, one hydrogen. So this is ethylene. So we want to know what is the hybridization of ethylene. So now the simplest way that we can do that is, of course, this is the carbon. So now the first thing we need to know is carbon having any lone pair of electrons. So we need to draw the electronic configuration of carbon. So carbon has atomic number of 6. The atomic number of carbon is 6. So in the first shell we have 1, 2 electron. Then in the second shell we have 1, 2, 3, 4. So we have 2, 4 electrons. So if you now check the whole of this compound, for the whole of this electronic configuration, all the electrons here are bonding pair. They are not lone pair. So it means that carbon have 0 lone pair. It has 0 lone pair of electron. So then the next one is, now you calculate how many atoms are directly attached to this carbon or any of the two. So let's take this carbon. So how many elements are directly attached to this carbon? Of course, it's 2. This carbon here and this hydrogen. So it means that there are 2 atoms that attach to the carbon. So we're now going to say 0 plus 2 is now going to give us 2. So it means that it is sp hybridization. So the answer to this question is option A. A is the answer, sp hybridization. And ladies and gentlemen, let me just give another examples on how to get the hybridization of it. Like for example, let's say we have NH3, which is ammonia, and of course nitrogen have atomic number 7. So we can now draw the electronic configuration of nitrogen here. So the first shell have 1, 2. So we now have 1, 2, 3, 4, 5. So you can now see clearly here in the nitrogen here, there are 1 lone pair of electrons. There is a 1 lone pair of electrons. So we have 1 lone pair of electrons. And then of course, how many atoms are attached to this nitrogen? Of course, there are 3 hydrogen atoms that are directly attached to this nitrogen. And of course, this represents the lone pair of electrons. So we are now going to say 3 atoms. So we now have 1 plus 3 making 4. So here, why do we have sp is because we have, it means that there is 1 s and 1 p. But in the case of sp, in the case of nitrogen, so in the case of ammonia, we have sp3 hybridization. 1 s, 3 p. So this is sp3 hybridization. So ladies and gentlemen, this is how to get the hybridization of an atom or of a molecules in a compound. or the hybridization of an element in a compound. The first thing is for you to calculate whether the atoms have any lone pair of electrons or it doesn't have. And then the second one is to check whether is to check first the lone pair of electrons and then how many atoms are directly attached to it. After you do that, then you sum them, then you get to a hybridization. So ladies and gentlemen, if this is the first time you are coming, please subscribe to my YouTube channel.